Our fourth lesson in this unit is on symmetry, and today we're going to talk about three types of symmetry. In elementary school, you talk about line symmetry quite a bit. You actually fold paper in half and make pictures out of symmetrical objects. But we're also going to talk about rotational symmetry and point symmetry, what happens when you start turning objects. So how do I find symmetry in figures? So this lesson will have a couple of vocabulary words that you have to make note cards for. The first one is line symmetry. Okay, stop and think for a minute. What did you learn about in Algebra 1 that had a line of symmetry? Ooh, a parabola, a graph of a quadratic equation. Did it at the end of the year last year, right? A figure has line symmetry if it can be mapped onto itself by a reflection in a line. Think of a mirror image. Okay, so let's look at this particular star, right? I could draw a line right here, and if I folded that star in half, it would match up perfectly. I could draw another one here, and if I folded it in on the green line, the star would match up perfectly, both halves. How about here? Yep, that would also work. It would fold up perfectly. Ah, that one also works. It'll fold up perfectly. Let me grab another color here. Purple. Oh, it still came out blue. There we go. Okay, so if I look at this particular star, I have 1, 2, 3, 4, 5 lines of symmetry. Be careful, the halves have to match up perfectly or this does not work. Another type of symmetry is called point symmetry. Okay, here's another note card for you. A figure has point symmetry if it is mapped onto itself by rotating exactly 180 degrees about a center point. So really this means it looks the same upside down. And if I look at the what we generally consider the not symbol, right, or like no smoking, no cell phones, whatever, if I put my center point there and I rotate this 180 degrees, does it look exactly the same? And the answer is yes, so this particular shape has point symmetry. The last type of symmetry we need to talk about is rotational symmetry. A figure has rotational symmetry. Whoops. Should have written a little smaller there. If it can be mapped onto itself by rotating the figure less than 360 degrees, about a center point. So I have a very fancy sun here. Let me put a center point in here. Let's see. This is kind of interesting. All right, I'm going to do this. If I rotate this angle, will that sun match up to itself perfectly? And I think it will. I'm going to go ahead and draw in all of those on this diagram. And then look at how many sections I have. 1, 2, 3, 4, 5, 6, 7, 8 sections. So 360 degrees in a circle divided by 8, 45 degrees. This has rotational symmetry at 45 degrees. And it has symmetry at every multiple of 45 degrees. So 45, 90, 130, 180, and so on. But we just take the smallest value when we talk about the rotational symmetry. Let me highlight that, make sure you make a note card for it. Let's try some of these. So we're looking at whether or not we have line, point, and or rotational symmetry. Okay. Line is usually my favorite to find. Let's see, I can fold right there. I can fold here. I can fold here. I can fold here. I can fold here. I can fold, let's get yet another color. Ooh, I don't know if pink's going to show up or not, but we're going to try it. Here. Huh. All right, so if this is 1, 2, 3, 4, 5, 6 lines of symmetry. Interesting. I have 6 lines of symmetry here. And I like finding my lines of symmetry because that helps me figure out everything else. So if I look at this, I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sections. If I rotate from here to here, will this figure look exactly the same? No, because I'm going from a middle to a vertice, that's not going to work. But let's look at a vertice to a vertice. What if I rotate from this green line to the red line? Is that going to work? 1, 2, 3, 4, 5, 6. 360 degrees divided by 6 is 60. This has 60 degrees rotational symmetry. 360 divided by 6 from vertice to vertice. All right, so a quick way to tell for point symmetry, and I can imagine that if I rotate this 180 degrees, it's going to work. But a quick way to check is my rotational symmetry, does that divide evenly into 180? And it does. 60 times 3 is 180, so 3 turns to get rotation point symmetry. Let's look at number 2. Okay, we've got a triangle here. Let's see, this particular triangle, whoops, I didn't draw that very straight. But I have a line of symmetry here. I have one there. I have one here. So yes, I have 3 lines of symmetry. Okay, if I turn that upside down, does it look exactly the same? No, if I turn it upside down, it's going to look like this. So I know I do not have point symmetry. What about if I turn it at another angle, will I be able to match a vertex to a vertex? And actually, I think that will work. I think we've got 1, 2, 3 angles here. 360 degrees divided by 3 is 120. So yes, we have rotational symmetry at 120 degrees. This is an equilateral triangle. Be careful, all triangles are not going to work. Number 3, you have a parallelogram. Let's see. No, that doesn't work. Let's try another line of symmetry. Not going to fold in half equally. What if I try on the diagonals? Nope, still doesn't work. When I fold that up, I will end up with something like this. So, no line symmetry. Okay, how about a center point? If I rotate that 180 degrees, yeah, that's going to work, right? And if you have point symmetry, you definitely have rotational symmetry. And in fact, 180 degrees and 360 degrees are the only way to rotate that parallelogram and have it come back to itself. Ooh, a scalene right triangle. None of the sides are the same, and it's a right triangle. Definitely not. Definitely not. Definitely not. Okay, no line symmetry. A center point? Maybe here? If I rotate that 180 degrees, it's going to look like this. So no point symmetry. Is there any other angle I can rotate this at and have it map right back onto itself, look exactly like it does now? No, this sucker has nothing. All right, we already talked about this star, and we know that it has line symmetry. Five lines, as a matter of fact. We talked about it earlier in the notes. Let's go back and look at point and rotational. If I rotate this 180 degrees, when it's upside down, right? A very bad drawing of my star, but the point that's currently on top is on the bottom, it's not going to work. So point is out, but rotational might. And let's see what happens when I connect the vertex to the center. I create 1, 2, 3, 4, 5 sections. 360 divided by 5. Each of these sections look to be exactly the same to me. So let's see, 72 degrees of rotational symmetry. So 72, 144, 216, and so on to go around that particular shape. That's an interesting thing. I don't even know what to call it. Some sort of patterny thingy. Okay, line symmetry is definitely out. I see absolutely no way to fold that in half and have it come out perfect. Point. Yeah, if I rotate that 180 degrees, that's going to work. Is there any other angle of rotation? If I go 90, it doesn't match up. 180 matches. I think rotational is only at 180 degrees. Ooh, look at our fancy letter A. That'll work for a line of symmetry, but nothing else for a line of symmetry. Let's see. Point, turn it upside down, definitely not going to look the same. Rotational, there's my center. Nope, that's it. It's the only thing that's going to work. Ooh, my lightning strike. What do you think? You are correct. Absolutely none of this is going to work out. Let's look at number 9, kind of like a pinwheel. What do you think? I see point for sure. I see 4 equal sections. So I see rotational symmetry every 90 degrees. Not sure what this is supposed to be either, but this random shape, what do you think? I'm catching two lines of symmetry. I think that yes, this will rotate 180 degrees and look exactly the same. And I also think that is the only angle it rotates at in terms of rotational symmetry. So I want you to take a minute to write a summary about the three different types of symmetry and how you find them.